So for our first example, let's find the volume of the region which is bounded below by the cone z equals root x squared plus y squared. So that's this cone. And above by the paraboloid z equals 2 minus x squared minus y squared. So here's that paraboloid. And so the shape whose volume we're trying to find is this shape. So this looks like a good problem for cylindrical coordinates. So we'll take some integral. Let's do it in the order dz r dr d theta. So theta, you can see, will go from 0 to 2 pi. R will go from, let's hang on for R for a second. R will go from 0 to something, and then Z will go from R, which is this, to 2 minus R squared. Again, x squared minus y squared, or x squared plus y squared is R squared. So to find the upper bound for R, we need to find where these two surfaces intersect. So if z is equal to r and z is equal to 2 minus r squared, these are our two surfaces. We'll set these equal to each other to get r equals 2 minus r squared. The solutions to that are r equals -2 and r equals 1. But since this is a radius, of course, what we want is r equals 1. So our integral is 0 to 2 pi, 0 to 1, and then r to 2 minus r squared, dz r dr d theta. So now we can start to evaluate this. This will be integral 0 to pi, integral 0, 1 of 2 minus r squared minus r times r dr d theta. So that so that becomes integral 0 to pi of 2r, so integral 0, 1, 2r minus r cubed minus r squared dr d theta. And so that's going to be, well, the integral with respect to theta is going to give it 2 pi. And then inside, we're just going to have, we'll evaluate r squared. So 1 minus 1/4 minus 1/3. So let's see. 1/4 plus 1/3 is 7/12. So we'll get, this will be 2 pi times 5/12 is 5 pi over 6 is the volume of this shape. Next, let's see how to find the volume of the solid which is cut from the cardioid of revolution, rho equals 1 minus cos phi, so that's the sort of apple-looking shape here, by the xy plane. So we're only interested in the part of this solid which is above the xy plane. So this looks like a good problem for spherical coordinates. So let's set up rho squared sine of phi, and we'll integrate in the order d rho d theta d phi. So then our bounds are going to be, so rho is going from 0 to 1 minus cos of phi. Theta is from 0 to 2 pi. And phi is going from, so 0 is straight up, and then the xy plane is when theta is equal, or sorry, when phi is equal to pi over 2. Okay, so we'll evaluate that. So this becomes integral 0 to pi over 2, integral 0 to pi of 1 minus cos phi cubed over 3 times sine of phi, and then d theta d phi. And we can see that since theta is a constant, we'll be able to integrate this out. Or this will just give us a 2 pi in front. Now to evaluate this integral, rather than expanding out this product, we'll substitute h is 1 minus cos phi, and so dh is sine, oh sorry, I erased the wrong thing, this should be d phi. ADH is sine of phi stop doing that. Sine of phi d phi. And so when so this is 2 pi integral 1 minus cos of 0 is 0, 1 minus cos of pi over 2 is 1, h cubed over 3 dh, and that is just going to be h to the 4, so 2 pi times 1 over 12, which is pi over 6. Lastly, let's find the volume of the solid which is bounded below by the xy plane. Then on the sides by the sphere of radius 2, so rho equals 2, and above by the cone where phi is equal to pi over 3. So here's that cone, and then the shape whose volume we're finding is this guy, so sort of spherical banded side, but then this conical divot. So this again looks like a good problem for spherical coordinates. So we'll set up a rho squared sine phi. In this case, let's go, let's do d phi, d theta, d rho. So our bounds for phi are going, so phi is going from pi over 3, so the top of our cone, to the xy plane, which is pi over 2. Theta again is going from 0 to 2 pi, and rho, the radius, is going from 0 to 2. Okay, so integrate that. Then, okay, so this is integral 0 to 0 to pi rho squared So negative cos phi evaluated at pi over 2 and at pi over 3 d theta d rho. So that will be, this one is 0, and then cos of pi over 3 is 1/2. So that's integral integral 0 to integral 0 to pi rho squared over 2 d theta d rho. Again, the integral over theta, since theta isn't part of this, we'll just pull out a 2 pi. So this will be just integral pi times the integral of rho squared from 0 to 2. Shorten that, so rho squared d rho, and so of course that is pi times 2 cubed over 3 is 8 pi over 3.